All right, here we go, guys. 10.4, the hyperbola. So we've been talking about the ellipse. The ellipse has two foci that are in the center of it. But what happens when you pull that foci out to the outside? Well, what you get is you get a picture that now looks something like this, where the foci is on the outside and it's pulling it to the outside, right? So it could either look like that, or we could change it the other way and have something that looks like this, right? So anyway, that's what we're going to look at today. These are called hyperbolas, and let's get right into it. So the definition of a hyperbola is the collection of all points in a plane where the difference of whose distances from two fixed points called the foci is constant. Okay, very similar definition to when we were talking about the ellipse. It's just kind of the opposite. So objective 1, analyze hyperbolas with center at the origin. So here we go. This is all when the center is not moved from 0, 0. Okay, so theorem 1, make sure you get this in your notes. Basically, what all this is laying out is what A, B, and C means with hyperbolas, and then the equation that we use to solve these. So A is just going to be the distance from the center to the vertice. C is going to be the distance from the center to the foci, and B is going to be the distance from the center to what we call the co-vertice. Okay, so make sure you get that in your notes, your A, B, C's. If the hyperbola is opening left and right, you'll know this because it will always start with an x squared followed by a minus y squared term. Okay, if it opened up and down, it would start with the y squared. So the first term tells you which way it's opening. Okay, so this is opening in the x direction, and when that happens, the standard equation here for one of these is x squared over a squared minus y squared over b squared is equal to 1. And then notice this, we are now back to the Pythagorean theorem, right? So if you solve that for c, for all of these, we can do a proof of this later, but c squared is now again equal to a squared plus b squared when you solve for c squared. Okay, so you just use the Pythagorean theorem to find your ABCs, and that's pretty much the big takeaway for this lesson. So let's just start using it now. So if we look at example 1, it says find an equation of the hyperbola with the center at the origin. One focus is at 3, 0, and one vertex is at -2, 0. Graph the equation. Okay, so they want the equation. All right, so to find this equation, first of all, what I would do is I'd probably draw just a little sketch. It says that one focus is at 3, 0. Okay, that means the other one has to be at -3, 0. Then there's a focus at -2, which means there's also a focus at 2. So we know it's opening this direction. Okay, so what we don't know is our B term. So we know that A is the distance to the vertex from the center, so that's going to just be 2. Okay, so a squared is equal to 4. We also know that c is the distance to the foci, which is 3, so c squared is equal to 9. And then we know that a squared plus b squared equals c squared. So I'm going to plug in what I know. 4 plus b squared equals 9. So b squared is equal to 5, which is really all I need for my equation. So once I have this, I can make an equation for it. Okay, and they give you the equation here. It's the x direction, so x squared is going to come first. We're going to put over the a distance squared, so 2 squared is 4, and then minus y squared over the b squared, which is 5, is equal to 1. Okay, so that's our equation, and that's all they want for this first example here. All right, then they want, if you're going to graph it, what they have you do here, you can pause the video and take a look at this, but what they're having you do is choose the focus point, okay, which has an x value of 3, and just plug it into your equation for the x. All right, so if you look at that carefully, that's what they're doing here. They're plugging in plus or minus 3 into this thing to get the points to graph it, right? So when you solve this out, you'll end up with this guy, y equals plus or minus, so that's essentially 2.5. So when you go to graph it, you know that at your focus, Okay, at your focus here, when you plug in, the y values are at 2.5. So you'd go, 2.5 up and have a point there, and then 2.5 down, you'd have a point there, and you can use that to kind of connect and get your shape going. And that's plus or minus, so it's the same on both sides. Okay, so you're essentially just plugging in a value for x. They chose to plug in they always choose to plug in the focus point. Okay, so, and then there's the picture of the graph, right? So jot that down, make sure you guys get that into your notes, study it a little bit, make sure you understand it. Example 2 says to use a graphing utility. Excuse me, so if you're gonna do that, you just need to solve this for y, right? I'm not gonna do all that here, but you could solve for y, and then you can use your TI to get a picture of this. And so they walk you through how to do that, the solutions here, so if you wanna look at it, you can. Kind of ugly, I don't like doing this, I'd much rather do it by hand. But there it is anyway. In your grapher, you always have this hole here. Don't worry, it's just because of how the graphing calculator does this, but there's not really a hole there. Example 3 says analyze the equation of the hyperbola. Okay, so we know here a couple of things. First of all, the center of this thing, the center is at 0, 0. We know that because there's no modification of x or y. Then we also know something else about this. We know that the a value is equal to 5 because a squared is 25. And we know the b value is equal to 3. Okay, so we can find where the foci are. So they want to know center, which was easy. They'll want to know the vertices, where the vertices are. So to find the vertice points, we know it's in the x direction. We know it's a distance of 5 from center. Okay, so if you think about that, x direction, 5 from center, those points there are going to be at 5, 0 and negative 5, 0. All right, they're also going to want to know where the, well, chances are they're probably going to want to know where the foci are, so we could find that, right? So to do that, it's just going to be a squared plus b squared, which we already know. We already know a squared and b squared. Okay, a squared is here, b squared is here. So c squared is equal to 25 plus 9, which is equal to 34. So the foci are going to be at this distance of square root of 34 from center. Okay, so foci are going to be at plus or minus square root of 34, 0. All right, so that's how they get that, is from that c squared equals a squared minus b squared. Sorry, plus b squared. So that's example 3, and then they have you plot this by plugging it in, and then you can get a point through your foci to graph it, right? So I don't know how they'll have you do that in your homework, but I wouldn't worry about this too much because I'm going to teach you a trick that you can avoid all that. So that's example 3. Okay, so we're kind of cruising through the first side of our notes here. Let's get into theorem 2. So here's theorem 2, and that's if we have a picture that looks like this over here, where it's opening up and down. Okay, notice the only thing that changes in my equation is the x and the y. So now the y squared term comes first when it's opening up and down. That's the only difference with any of it. Okay, everything else still holds true. So make sure that's in your notes. And then example 4, we'll get into one of those. Notice here that I want you to solve this first, so that we have to set this to equal 1, right? So we have to divide everything by 9, and when we do that, we get this guy, where the y squared term is first. Okay, so what that tells me is, I know it's opening up and down. All right, I know my distance from center is at 1, 1, right? Or sorry, at 0, 0, and my distance is 1. Okay, so I have a vertex here, a vertex here. I have a co-vertice at 3. Okay, so I'm going to teach you something new here. Okay, so really what you can do is, when you find out what your A and your B is you can map those out and you can draw this box. This box between these, if you were to draw like a dotted line through the corners of that box, that actually gives you the asymptotes. That gives you the asymptotes for the graph, so you know where it's bound. Okay, so once you have that, that's a little bit of a nice trick there. They're still going to want you to figure out what the foci are, right? Which will be the square root of 10 here, because c squared is equal to 1 squared plus 9, shouldn't say 9 squared, 1 plus 9, because it's already squared. So c then is equal to the square root of 10, plus or minus. Okay, square root of 10 is somewhere between 3 and 4, so we know that it's going to be right in here. Sorry, this is opening up and down, so it's going to be this way. So somewhere up there, 1, 2, 3, just past 3, and then 1, 2, 3, somewhere in there. Okay, and then we could plug that back in and get a point, or we can just say, oh, we know where this is bound, right? So we just drag this graph out to the asymptote. By the way, your asymptote, just so you know, this is coming, but your asymptote is always your change in y over your change in x. Okay, so if you'll notice here, the y value, what's related with y is this 1, and what's related with x is 3, because this is 3 squared is 9, right? So it's just going to be, when the y squared term comes first, it's just going to be a over bx. Okay, so here the a term is 1 and the b term is 3. And don't worry if that's not making good sense yet. I'll make sense to that in just a minute. But you have a line that is plus or minus 1/3. And that is going to be your asymptote where this thing is bound. All right, so that's how you do that. Let's keep cruising here. It looks like my Apple Pencil just ran out of battery or something, but we'll make it work. Okay, so example 4, this is just going through the algebra of it all. This is how they would locate a point if you wanted to plug something in. If you notice they plug the focus in here, right? So they plug the focus point in, they solve it for x, and then you see what happens at the focus if you just want to use a point, since they haven't taught you the asymptote rule yet. So you can do that. You can study this a little bit and try that out. I'm not going to spend the time on it right now. But here's where they use their points to figure out how wide it is, right? So you could plug in your focus point, plug it in for y in this case. Okay, so they plugged that in for y and they solved for x. And when they got x, it was plus or minus 9, which is how they got these points. Okay, again, I'm going to teach you a little trick so that you don't have to do all that. I don't know what the program will make you do for your homework, but we'll do a little trick. Okay, so example 5, moving right along into example 5, it says find an equation of a hyperbola that has a vertex at 0, 2 and a foci at 0, -3 and 0, 3. All right, so for this one, I would first sketch myself a little bit of a picture for this. So if it has a vertex at 0, 2, you're up here and down here, and then it has a foci at 3 and -3. So we know that this thing is going this way. We just don't know how wide. All right, so I can use I know that my A value is equal to 2. I know my C value is equal to 3. So A squared is 4. So we know that C squared is 9. So I can say 9 is equal to 4 plus B squared. So B squared must equal 5. All right, so then when I'm, and the center's at 0, that makes it easy. So since this is opening up and down, I'm going to use y first. So I can say y squared over 4 minus x squared over 5 is equal to 1. Okay, so they just want the equation, and then they want you to graph it. So we kind of have an idea here. Again, I'm going to show you how to do this with asymptotes right now with the box method. Okay, so we already know our vertices. We know this. The distance in the x direction would just be the square root of 5, because that's my b value. Okay, so in the x direction, I'm just going to go just past 2 here, just past 2 on this one, and I'm going to draw this box. Okay, I'm going to do a dotted line through the corners of the box. That tells me that's basically my slope, my asymptote, and I know this thing will be bound to those asymptotes. Okay, so it's going to look something like that. All right, again, they plugged in the focus point to get exact values. So if you plug in a plus and minus 3 into our equation right here, okay, they plugged in that for y and solved for x. When they got that, they got 5 halves and negative 5 halves for both of these. Because there's a squared term, it's going to be the same for all of them, right? So feel free to do that. Feel free to plug things in. To help you make sense of this, you can always, whenever you're learning to graph something, you always choose a value to plug in and solve for the other value. Here they're choosing to plug in a y value because y is first. Okay, objective 2 says find the asymptote. So I've been talking about this a little bit. So the asymptote is simply this. If you have x squared over a squared minus y squared over b squared equals 1, that means that we have a hyperbola that's going, in the x direction. Then we know that the y value is associated with b and the x value is associated with a. Therefore, my asymptote is going to be y is equal to b over a. The asymptote is always slope, so it's always y over x. Change in y over change in x. So here, that is b over a, plus or minus. If it was going the other way, and you had y squared over a squared minus x squared over b squared, then you know your slope would be change in y, a over change in x, which is b. So you have plus or minus AB, A over BX. Okay, so that's your asymptotes. And again, if you use the box method, what the box is giving you is it's giving you that slope. Okay, because it gives you the change in A and B within that. So let's look at 6 here. It says analyze the equation of y squared over 4 minus x squared. So we know this is opening up and down, right? We know that the value to the vertex is going to be 2. So we have a vertex here, vertex here. We know that in the x direction, we only have a value of 1. Okay, so you can draw this little box in like this. You can draw these little things through here. Okay, and then you know that that is your asymptote, right? So it's bound by this, and you're done. If they want to know the coordinates of the foci and all that, you can find it using a squared plus b squared equals c squared, which they did, right? So, it depends on what they're looking for. But in this case, we have a slope of 2. Okay, because it's the change in y, the square root of 4 is 2, over the change in x, square root of 1 is 1, 2 over 1 equals 2. From here, I'm going up 2 over 1 on this line, up 2 over 1, and then down 2 over 1 on the other line. Okay, so that's where those asymptotes come from. And I know this is a little rushed and you probably have a lot of questions. That's okay. Just get the gist of this and we'll work through the rest of it. So example 6, I think we just did that one. Let's cruise on here. I want to get to a little bit harder stuff. So let's look at example 7. So if they want you to analyze this, let's analyze this real quick. So first of all, we need to get this equal to 1. So let's divide everything by 36. So I get x squared over 9 minus y squared over 4 is equal to 1. So I know this is in my x direction is the way that it's opening. Okay, so it's going to be doing, and a distance is 3. So I have something like that. In the y direction, we have a 2, okay, because the b value is 2. So there's our little box that we could use. Draw your asymptotes through there. You can kind of see how wide your hyperbola is going to be. So it looks something like that. Okay. Get this drawn in here a little bit better. Something like that. Okay, so center's at 0, 0 here. We know our a value. We know the coordinates of the vertices. We can figure that out really quickly. You can just plug in A and B and solve for C and know where the foci are, right? Which I'm not going to do all that right now because we've already done a lot of that and I don't want this video to drag on. But you could figure all that out. So example 7 was just showing you a little bit more of the algebra. And then the last little bit of this is what happens if we shift the center so it's not at the origin. Okay, so just know that if you shift the center, then if you look at this chart, it's just like everything else, right? So whatever makes it go to 0 is how I'm going to shift it. So for instance, if I had a center at 1, -2, Then, well, let's just do one. So example 8 says find an equation of hyperbola with center at, well, there it is, 1, negative 2. One focuses at 4, negative 2, so 1, 2, 3, 4, negative 2. And then it says, and one vertex is at 3, negative 2. Okay, so I know that this thing is going to open this way and this way. Okay, so since I know that my x value is going to come first, and I know that I have to modify it by 1. So it's going to be x minus 1 squared minus y plus 2 squared. Okay, because it was minus 2, so that will make that go to 0, equals 1. Okay, so I got to figure out what my distances are. So my distance from the center to the vertex, so say here it says center's at 1, negative 2, vertex is at 3, negative 2. That's a difference of 2. So 2 squared is 4. I know that my focus for this thing is going to have a difference of 3, right? So if you look at the focus difference, 4 minus 1 is 3. So I can say, okay, c squared equals a squared plus b squared, right? So I know 3 squared is going to be 9. And my a value is 4, so or is 2, sorry, so 2 squared is 4, so that means that b must equal 5. So sorry, I should say b squared should equal 5. So this is going to be 5, and that's my equation. And all they want is the equation, I think, for this, and then they want you to graph it. So you can graph it then. I'm not going to go over the asymptote line, but the asymptote essentially is the slope is always going to be the same, right? So this is going to have a slope of square root of 5 over 2, because it's going to be the change in y, square root of 5, over the change in x, square root of 4, which is 2. So it'll be root 5 over 2 is the slope of the asymptote. And then I have to adjust the center, right? So I can just show you that. So center's at 1, negative 2, so therefore my y value I have to adjust. So I have to say y plus 2. And then that's my slope, and then it'll be x minus 1. Okay, so that would be the equation of the asymptote if you needed that for some reason. All right, the last little bit here, I think I'm going to just end the video now, but for this one, all you're doing here is you're going to group your x terms together, group your y terms together, complete the square, right? And you're left with this guy. So you can pause the video and look to see how they did that. And then down below here, they show you, once you find all that, they show you how to come up with the asymptotes, they show you how to come up with the foci, the vertices, all very related to what we've been doing this whole time. So I'll stop that there just for the sake of time, and definitely you'll be probably asking questions about this next time, but that's all right. All right.